Okay, in the final problem of this section, we have in baseball a player's batting average is calculated by dividing the number of hits by the number of at-bats. So you may not be familiar with baseball, but you're told how to set up the batting average. Batting average is calculated by dividing. So first of all, we're going to divide. So we would say batting average is the number of hits. So it will be hits divided by the number of at-bats. What does at-bats mean? At-bats means the number of times that you go up to try to hit, that you have the opportunity to hit. You may strike out, you may ground out, you may fly out, you may get a hit, you may get a home run. Any hits, singles, doubles, triples, home runs are all considered hits. Any outs are not hits. So you take the number of hits and divide by the number of at-bats, the number of opportunities you have to hit, and that will give you your batting average. Alright, so let's see what we have here. In part A, we're asked how many hits did player A have in the 2011 regular season. So all of these statistics are for player A. So we're first interested in the 2011 season. Now remember, we know that batting average is hits over at-bats, and again we have three quantities and we're given two, so we can solve for the third. So the question is how many hits? We'll set up an equation that might look something like this. Batting average we know is 0.296. The number of hits, we'll call them X, over the number of at-bats, 446. And when we multiply, so rather I should say we solve for X by multiplying both sides by 446. And when we do that, we get that X is equal to 132.016. Now, what is X in this case? It's the number of hits. Can you have 0.016 hits? You really can't. There's no way that that can happen. So we can only imagine that batting averages are usually given to 3 digits, and we would say that person has a batting average of 296 or 296, even though it's really 0.296 or 296 thousandths, which means roughly 296 out of 1,000. So there must have been some rounding to get to 296, and because of that, when we multiply back, we're going to get a fraction here. So we would assume that this is 132 hits for part A. Now for part B. Part B talks about player B, but all of the statistics in the table that we have there are for player A. So player B has to have something else, has to be something else that's not listed in that table. Player B had 33 fewer hits in the 2011 season than player A, but had a greater batting average. Your friend concludes that player B had more at-bats in the 2011 season than player A. Is your friend correct? So let's see what happens. Now, this is similar to one of the problems that we talked about before. We have a number of quantities in a problem, and as one goes up, how does that affect the other? So let's talk about this for a second. Player B had 33 fewer hits. So do we know how many hits player B has? Player B must have had 132, which is what player A had, minus 33. So that would be a total of 99 hits in the 2011 season. Alright, so we go back to our formula and we put in that the batting average remember is equal to the number of hits, which would be 99 over the number of at-bats. We'll call that capital B, or B for bats. So we still have two quantities that are missing here. We don't know the average and we don't know the number of at-bats, but we are told that player B has a greater batting average, and the batting average is calculated by 99 over B. So we know that the number of hits, 99, over the number of at-bats, unknown, has to be more than 0.296. So let's see. Now your friend concludes that player B had more at-bats in the 2011 season than player A. So is it possible? Now player A had 446 at-bats. So player A had 446 at-bats. Now, if we put 99 over 446, we would get 0.221 for a batting average. And is that greater than 0.296? It's not greater than 0.296. So if they had the same number of at-bats, then player B should have a lower batting average than player A. Now, if player B had more than 446 at-bats, think about what happens as we increase the quantity B. Let's put 500 in there. If we put 500 at-bats in, then 99 hits, which we know player B has, over 500 at-bats would give us an average of 0.198, which is not greater than player A. So player B has fewer hits but has a higher batting average. That must mean that player B has fewer at-bats than player A. So we'll scroll down a little and put in that conclusion. And it goes like this. Since player B has fewer hits but a higher batting average, they must have had fewer at-bats. So your friend is incorrect. And that does it for this problem.